Alright, so we're on lesson 12, or lesson 10. Nope, not that either. We're on lesson 11 today. Our I can statement is I can multiply a decimal fraction by single-digit whole numbers, relate it to a written method through the application of an area model, and place value understanding, and explain the reason used for it. So basically what we're doing today is we're multiplying decimals using area models and place value strategies, and then we have to be able to explain why these are going to work for us, why these strategies work. Alright, so let's look at our very first one. So we have a problem, 3 times 2/10. So what's that going to look like? Well, here's my single digit number that I heard my I can statement, and I'm multiplying it by 2/10. So what I'm going to do is I'm going to put my tenths as dots. I see 2/10, and now how many groups do I have of those 2/10? Well, this is one group, but I need 3 groups. I need 2, 3 more. So that will be 1, 2, 3, 4. So now I have nothing left to multiply, so now I can just add them up. And what do I get? I see 1, 2, 3, 4, 5, 6. So I'd have 1, 2, 3, 4, 5, 6 dots. So guess what this answer equals? It equals 6. Also, if I just line them up, remember, since I'm multiplying, it doesn't matter if I do 3 times 4 or if I switch the other around, I'll still get the same thing. So that's why I've switched this one down here instead of copying it like this. If I multiply like normal, I get 3 times 2 is 6, and then where does this decimal go? Well, I see by my area model my decimal will go right here because I need to have tenths. Alright, let's look at another one. So here I have 3 times 3/10. Well, here's my tenths, so I'm going to put 3 dots, 1, 2, 3. And how many groups do I have? Well, this 3 is telling me I need 3 groups, so I need to have 1 group, 2 groups of 3, then 3 groups of 3. Then I count them all up and I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. That would be 9/10. Can check also with my standard application, my standard algorithm, and this will be 3 times 3 is 9. And I see here I'm in my tenths, so that means my decimal has to be added here, so it is also my tenths. Okay, and then just to keep our pattern going, by multiplying by 3/10, I'm now going to have 4 times 3/10. I have 4 dots, 1, 2, 3, 4, and I have, oops, I did that wrong, I don't have 4 dots. I have 3 dots in my tenths, and I have 4 groups of them, so that will be 1 group, 2 groups, 1, 2, 3, 3 groups, 1, 2, 3, 4 groups, 1, 2, 3. So if I look, that means I have 12/10. But I need to remember from yesterday's lesson, the day before, what do I do when I have a group of 10? Well, when I have a group of 10, they go over to the next place value. I exchange them. So this is actually going to be 1 dot and 1, 2. Those 2 right there, which is 1 and 2/10. I see the same thing happens when I just count the red dots. This 10 needs to be traded over here as well. So either way, I get that same answer. Standard form, it would be 1 and 2/10. I can also see by multiplying it using my standard algorithm. 4 times 3 is 12. And where does this decimal go? Well, if I look here, I see it separates my ones and my tenths. So it would need to go right there. Alright? Now, let's look at our next one. I'm going to have a 2-digit number I multiply by 2 times 43 hundredths. So I'm going to look, I have 4 here in my tens, 1, 2, 3, 4, and 3 here in my hundredths, 1, 2, 3. How many groups do I have? Well, it says there's 2, so that means I need to make 2 groups. Here's one group and one group, but there needs to be 2 in each section. So remember, this is from 4th grade. This is called partial products, is what we're going to be working with. I'm doing 2 times 4 tenths. That would be 1, 2, 3, 4. There's my second group. And 2 times 3 hundredths, which is 1, 2, 3. I need 2 groups where each of my place values are. So now I can add my dots up. This will be 1, 2, 3, 4, 5, 6. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, which is 8. So here I have, in standard form, 0.86, or 86 hundredths. If I notice, I can also break it up using my standard algorithm. 2 times 3, well, that is 6. 2 times 4, that is 8. And where does my decimal go? Well, this 8 needs to be in a tenth spot, and that 6 needs to be in a hundredth. If I look at that area model. Also notice, I can break this up into a kind of expanded form. I can do 4 tenths times 2 plus, and now I might need to actually erase so I have more room. 4 tenths times 2 plus 3 tenths times 2. Not 3 tenths, 3 hundredths times 2. And that will also give me what? This will be 8 tenths plus 6 hundredths, which also equals that same number. So here I have 3 methods to check my work. Okay, let's look at another one now. I'm going to have 2 times 423 thousandths. So what am I going to start with? Well, I'm going to start with putting my dots in each place value. 1, 2, 3, 4, 2, 1, 2, and 3 in my thousandths. 1, 2, 3. How many groups do I need? Well, there needs to be 2 groups, and right now I only have 1 group in each section. So this needs to add some more. So this will be a second group, 1, 2, 3, 4, 1, 2, second group, 1, 2, 3, second group. So now I can just add my dots up, and I see I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, which would be 8, 4, and 6. In standard form, it would be 846 thousandths. If I check it with my standard algorithm, just to make sure I'm always checking my work, I'm going to get 2 times 3 is 6, 2 times 2 is 4, 2 times 4 is 8. Where does the decimal go? Well, if I look at my place value chart, I see I don't have any 1s, and my decimal is right next to that 8. Now, let's just check it with one more method using that partial products. I would have 0.4 times 2 plus 0.02 times 2. This is going to be 0.8 plus 0.04 plus, and this one I'm just going to need to squeeze up here, 0.003 times 2, which is, and as I know from adding decimals, I only add like units, So this will be 0.846. Notice how I always get that same answer, no matter which strategy. Alright, let's look at another one. Just keep going with these examples. I'm now going to have 4 times 0.423, or 423 thousandths. So I have 4 tenths, 1, 2, 3, 4. 2 hundredths, 1, 2. 3 thousandths, 1, 2, 3. Now, how many groups do I have? Well, I see there needs to be 4 groups. Here I only have 1 group. So I need to make 4 of them. 1, 2, 3, 4. 1, 2. 1, 2, 3. I'm at 2 groups. I need 4 of them, so I make my third group. 1, 2, 3, 4. 1, 2. Third group. 1, 2, 3. Third group. I need to make my last group. 1, 2, 3, 4. 1, 2. 1, 2, 3. So here I have 2 strategies. I can just count up all my dots first, then regroup, or I can regroup them now. So what I'm going to do is I'm going to regroup them now. I have 9 dots here, and then I'm taking 1 from that 4th group, and I'm trading it. I'm left with 1, 2 dots. These 10 were regrouped as 1 dot. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 dots. So I do not need to regroup because I do not have a group of 10. Now let's check here. I have, more than 10. So I am going to take a group of 10 dots and I'm regrouping them. I'm trading. Now let's check how many I have. I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I have this 1 dot all by itself. So my answer is 1.692, or 1 and 692 thousandths. That was a lot of dot counting. So let's just check using our standard algorithm. Does it work? So I have 0.423 times 4. 2, carry the 1, 9. This is going to be 16. And where does my decimal go? Well, this area model is really nice because it's showing me I have 1 whole 6 tenths, so I just need a decimal to separate them. Now let's try using our partial product strategy and see if that works as well. That would be 4 tenths times 4 plus 2 hundredths times 4 plus 3 thousandths times 4. This is going to be 1.6. This will be 8 hundredths, and this is going to be 12 hundredths. If I add them up, I know my like units get added together. There aren't any thousands, so this thousandths is by itself. I add my hundredths, so 1, 8, that's 9. 8 plus 6 is what? I'm sorry, not 8 plus 6. 9 plus 6 is what? Well, that's going to be a 5. And then I'm carrying. So I'm seeing there's something wrong with this. So what I'm going to do is I'm just going to stack them for myself. I need to make sure their place values are all in the same spot. And there we go. So I see that 2, I see that 9, 6, 1, and I only have the same place values. And notice how they are still all the same. So even when I'm working with these larger ones, I still get that same answer. Alright, so now we're going to try a few problems that are going to seem similar, but they're going to be slightly different. So what I'm going to do is I'm going to be doing the exact same problems we just did, which is, we remember, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. We got for our answer 86 hundredths. But now I'm just going to show you how we can also model this using our area model. So remember, for our area model, I'm going to look, how many place values do I have? I have 1, 2 place values. So I'm just going to be drawing a rectangle, and I'm splitting it up into 2, my 2 place values. This is going to be tenths, and this is hundredths. And then I'm going to have 2, its length is 2 because there's 2 groups, and here its width is going to be 4, and my units is that tenths. Here it's going to be 3. So when I multiply these, what do I get? Well, here I get 2 times 4, which is 8 tenths. 2 times 3 is 6 hundredths. And I see that gives me the same thing as this dot plot type model. 8 tenths, 6 hundredths. Now what if instead I had this problem that we had? Then I'd have 1, 2, and there's 2 groups of that, so my answer should be 8, 6, 4. How do I model that using the area model? Well, my area model, I start by drawing that rectangle, and I'm breaking up into how many groups this time? Well, I have 1, 2, 3 place value groups. So I break it up into tenths, hundredths, and thousandths. I multiply it by 2, which means there's 2 groups, and I'm just putting that label on top. 4 tenths, 3 hundredths, 2 thousandths. And now what I do? Well, 2 times 4 is 8, 2 times 3 is 6, 2 times 2 is 4. And I would get 0.8 tenths, 6 hundredths, 4 thousandths. And look, it matches that problem we had there. Now what if we had, though, this slightly larger problem? 4 times 0.432. Well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Remember, there's 4 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. This would be 8. Remember, I have this group, so I bring it to the next one over. Here I have a group of 10, so it is brought to the next one over. I'm left with 1, 1, 2, 3, 4, 5, 6, 7, 2. So let's check. I believe Mr. Wimbley might have made a mistake. So I'm just going to be checking my algorithm, and then we'll see where that mistake was. 8, 2, 7. Okay, so that one is correct. Oh, I remember what the problem was before. I had switched these two. That's why it was different. So this is going to be a slightly different problem, but we'll still see how the same idea works. So what I'm going to do is I draw my area model, that big rectangle, and I notice there's 1, 2, 3 place values. So it's going to be broken up into 3 again. Tenths, hundredths, thousandths, 4. So I'm going to write that 4 on the side. And there's what? 4 tenths, 3 hundredths, 2 thousandths. 4 times 2 is 8. 4 times 3, that's 12. 4 times 4, that's 16. So now what do I do? Well, now I need to regroup. I have a group of 10 here. I have 12 tenths. So I need to take 10 away and regroup them over here. So that's going to be 16 plus 1 is 17. Taking 17 tenths, and I'm taking 10 away. because that has to be regrouped now. 2 1s. And I have 1 1. So I'd have 1 1, 7 tenths, 2 hundredths, 8 thousandths. And look how my answer matches. Either model or method that I use, I still get the same. Alright, so what we're going to do is we're going to try just 2 more. And then you guys are going to do your exit ticket. And then you're going to work on your project. So here I have 7 times 2.41. 7 times 2 and 41. So what I start out with is my dots, 1, 2, 1, 2, 3, 4, and 1. How many groups do I have? Well, I have 7. So there's 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups. Then here I need to have 7 groups also. 1, 2, 3, 4, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups. And here this one will be easy. 1, 2, 3, 4, 5, 6. And there are my 7 groups. 1 dot, 2, 3, 4, 5, 6, 7. Okay, hundreds will be easy. 7. This one though I have a lot of regrouping to do. So I need to take those groups of 10 and trade them. So there's 1 group of 10. 6 plus 4. There's another group of 10. And then 8. So I have an 8 here. And now let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I don't have any place to put them, so what do? Well, I just need to remember that this will be a 10 dot right there. And then I have 6. So what do I have? Well, I have 1 10, 6 1s, and 87.87. Okay, so let's use this area model to verify our answer. I start out with that big rectangle, breaking up into 1s, 10s, hundreds, 1s, 10s, and hundreds. It's 7 long. I have 2 1s, 4 tenths, 100. 7 times 1 is 7. 7 times 4, that's 28. 7 times 2, that is 14. I need to regroup 28 as 8 and 2 1s. So that's 14 plus 2 now is 16. And that 1 will regroup as a 10. So I have 16.87. Notice how they're the same. So my last step is I'm just going to check using my standard algorithm. 2.41 times 7 is 7, 8. Carry the 2. And look at that, all my answers match up. Alright, so what you're going to do now is you are going to work on your problem set. On the back side of the problem set, you're going to have your exit ticket. Then when you have turned your exit ticket into the box, what you're going to do is you are then going to work on your math project. Alright, good job today, guys.